Okay, for this video we're going to be looking at writing addition and subtraction expressions. Okay, so we're going to look at writing addition and subtraction expressions. Now, one thing I want to note before we get started, if we're talking about an expression, okay, we're talking about this word right here. An expression does not include an equal sign. Okay, normally when we're thinking about our number sentences, we have an operation, we have a couple numbers, and then we have an equal sign and an answer. If we're talking an expression, there is no equal sign. Okay, that's really important for us to remember going forward. Okay, so what I want us to do is I want us to create a tape diagram to show 3 plus 5. So for my tape diagram, I'm going to have 1, 2, 3. So there's my 3. And then 1, 2, 3, 4, 5. There's my 5. Okay? And if it's 3 plus 5, I know that I would have a total here of 8. Now, if I wanted, based on what we learned about yesterday, I could do it this way. I could start with my 5 and add to that my 3. Okay, so either way, I would have a tape diagram showing 3 plus 5 or 5 plus 3. If I needed to write that out as an expression now, I could write it one of those two ways. So I could either write it 3 plus 5, or I could write it as 5 plus 3. Because we know based on our commutative property of addition, the order really doesn't matter. Okay, our next example, how can we show 10 minus 6? So again, I want to show a tape diagram for 10 minus 6. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So here we go. Here's 10. And now if I subtract 6 from that, that'd be like taking away 6. So 1, 2, 3, 4, 5, 6. Okay, which leaves us left here with 4. And again, if I needed to write that as an expression, I'm going to start with my 10 and subtract from that 6. Now, could I write it as 6 minus 10? Well, if we think about it, is order important with subtraction? Yeah, order is important with subtraction, so I can't write it like that. Okay? I can't start with 6 and then take away 10. If I was to try to write that as a tape diagram, if I have 6 blocks, there's no way that I can take away 10 of them. Okay, it wouldn't work out. So the only way to write this expression is 10 minus 6. There is no commutative property for subtraction. Order is important. Okay, so for this example, we say a number increased by 2. Now, we have to be paying attention here. For this problem, they're saying a number is being increased by 2. Do we know what that number is? Well, no, we don't. We don't know what that number is, meaning that number is going to be our variable. Okay, if we think back, a variable is a letter that represents a number. So because we don't know what this number is in this case, the number being increased by 2, we're going to represent that number with a variable. So I'm going to say we're going to represent it with n. Okay. Now, if I wanted, I could show this with a tape diagram. I could say, okay, here's my n. That's my n, and I'm increasing it by 2. 1, 2. Whoops. Don't want that. And I'm increasing it by 2. Okay? If I needed to write this as an expression, okay, if I needed to write it as an expression, I would have n plus 2. And now if I'm thinking, okay, because it's addition, I can be using the commutative property of addition, so I could also have 2 plus n. Either one of those would work for an expression in this case. Main takeaway is, if we don't know what that number is going to be our variable, so that's going to have to be a letter representing a number. Okay, our last example here, it says write an expression to show c minus the sum of a and b. C minus the sum of a and b. Now, we can see that there's a couple different things going on here. There's a couple different operations. I see the word minus, and I see the word sum. So we see the word minus, we know we're talking about subtraction there. And I see the word sum, so I know I'm talking about addition here. So I need c minus the sum of a and b. So if I just start writing that out here as my expression, c minus the sum of a and b. So the sum of a and b, a plus b, c minus that. Now, here's where we have to be paying attention, okay? And this just involves careful reading. It's c minus the sum of a and b. That word sum, right here, is really telling us it's the answer to an addition problem. So if I need to take c minus the sum, or c minus the answer to an addition problem, I need to do that addition problem first. And in order to do that addition problem first here, order of operations, I need to put it in parentheses. Okay? Parentheses again tell us that those are important. We need to do that first. Well, because I'm c minusing the answer there, I need to find that answer before I can subtract it with c. So I end up with c minus a plus b. Now if I'm thinking to myself, is this the same thing as just saying c minus a plus b? No, it's not. Okay, order of operations tells us that these are going to give us different answers. Okay, on the left-hand side, I would have to do a plus b first. On the right-hand side, I would do c minus a first, giving us two very different answers there. Okay, that one is not going to be right. The c minus in parentheses a plus b is right because we need to subtract c with the sum of a and b. So we need to find the answer of a plus b first.